This is Wiley. We're going to do a little math together today. And to start with, I'm going to share a story with you. So there was a boy named Jose, and Jose goes to the store, and he is going to buy some gum. And in each pack of gum, there's 7 sticks of gum. And he ends up buying 11 packs. So I don't want you to write anything down yet. I want you just to turn and talk to your partner about what's happening in this story.
He's buying gum, and there's 7 sticks in each pack, and he ends up buying 11 packs.
11 packs, yes.
Okay. So who can tell me what's happening in the story? Yes.
Jose is gonna buy gum, and there's 4 sticks of gum in each pack, and he buys 11. Oh.
It's all right. Okay. So we know that he is buying some gum, and there's 7 sticks in each pack, and he's going to get 11 packs. During the time with your partner, how could you figure out how much he has all together? How many sticks of gum?
You could multiply 7 times 11, or you could do adding, but that would be hard. So multiplication.
So what are you guys thinking? What would you do?
Multiplication.
Do you guys all agree?
Yeah.
Why would you multiply? Yes.
He's buying 7 sticks. There's 7 sticks of gum, and he's buying 11 packs.
So how does that tell you to multiply? Who can add on? Yes, Savannah?
You know how many sticks, you know how many he bought already, but you don't know how many sticks he has together.
Okay, so how does it tell us to multiply?
Because you know how many packages he bought, and you know how many sticks are in each package, but you don't know how many total sticks you have together.
So you're thinking of the packages like groups, and so you have all these groups, and you're going to put them together, and so you know that if you have groups, you can put them together faster by multiplying. What would be the other operation that you could use that might be a little slower? What?
Addition.
So you could add all of the groups, or we know that we can multiply, and that will tell us how many. So go ahead and try and work that out. How much gum would he
Use the standard algorithm strategy. One is like 2-digit by 1-digit.
Okay, so what did show us? What did you do?
I put 11 times 7, and 7 times 1. 7 times 1 is 7. And then I put 7, and then 7 times 1 is 7. So I put the 7, and I got 77.
Okay, so this 7 was actually a 70, not a 7.
Yes.
Yeah, so we had 77. Oh, okay. Who else can share? Who wants to share? Go ahead.
I did the box method. So I broke the 11 apart, and I got 10 and 1. So I put a 10 right here and a 1, and I added a box and put the 7 right here. And so then I put a line here, and then I knew that 7 times 10 equals 70, and I knew 7 times 1 equals 7. So I added 70 plus 7, and it equaled 77.
Okay, who has questions about that strategy? Not able to follow? Okay, so let's look at these 2 strategies side by side and compare them. Turn and talk with your partner. How do these seem the same, and how are they different? What do you notice about these 2 strategies?
So when you do the box method, yours,
They're
it's a
different
box, and it's
because one
split
has a
from
box and
10, so you break up 11 into 10 and 1.
Up and down.
And you
Yeah,
put
and
10
we
on
break
the
it
top.
up.
Yeah. And then on that one,
to break up
like,
one
it looks like adding, except she multiplied
Sometimes you
it
don't
by
have
11
to.
times 7. Then, yeah.
So how are they the same? What did you guys notice? How are they the same? Yes?
Because they both are multiplying the same thing.
In what way? What do you mean?
Like they're both multiplying 11 times 7.
Okay. How else are they the same or similar? On this one, we didn't do times 11. we did times 10 and we did times 1. In this one, what did we do?
We just
11.
left it.
We did times 1 first, right? And then times 10.
Yeah.
So in both of them, we're doing times 10 and times 1, but in this one, we broke it apart and we started with the 10. In this one, you started with the 1 and 1 across. So if we look at this one, where do you see 7 times 10 in this one? Right? 7 times this is a 10. So 7 times 10, and we got 70 down here. Here, we kept the place value, so we actually wrote out the 10 and made it a 70 and then added them together. Did you have to add in this one?
No.
Why didn't you have to add in this one? Go ahead.
Because you didn't have any partial products.
Okay, tell me more.
You didn't have to add because you're multiplying.
There wasn't any real regrouping, right?
No.
And so when you put the 7 down, it could just stay in this place in the 1s,
Yeah.
and this one could stay in the 10s. So that's why you didn't have to add anything else. It was already in the right place. And this one, we just had to put them together. Okay, so we're filled on this a little bit more. So Jose went to the store. He was buying some gum. He got 11 packages. There were 7 pieces in each package, and he's going to share with everyone in the 4th grade class. And he knows that there are 68 students in the 4th grade class, and he wants to know how many extra pieces of gum he'll get to take home. So turn and talk with a partner. How do you think you'd figure that out?
I think you figure it out by subtracting because usually when you want to find out how much more you have left over, you're subtracting because you split it up with somebody.
68
Yeah.
kids in total, so I think you're gonna have to subtract.
Okay, sounded like everyone said subtract. Who can prove it? Why would we subtract? Yes.
Because we already know there's 77 pieces of gum, and he wants to share them with 68 people in his class, and he wants to know how much is left over.
So when you're figuring out leftovers, you're finding the difference in those two numbers. So when you're comparing them and getting the difference, you need to subtract. Okay, so let's work it out and see how many extra pieces. Looks like we've got 2 different answers, 9 and 14. Who would like to defend their answer for the group?
Oh, 68.
Oh, got it? Okay. Who'd like to share what they did? It looks like we had similar strategies this time. Volunteer? Sure, go ahead.
So what I did is I subtracted 77 from 68, and I knew that you couldn't subtract, I know that you can subtract 8 from 7, so, 7 minus 8. So I took a 10 from the 70 and I added it to the 7, and that gave me 17, and I subtracted 17 minus 8, which was 9, and 60 minus 60, which was 0.
Okay, so who has questions about this problem? Everyone feel good with that? Yeah? Okay, so we're going to do a different problem. So what we did was we just did a 2-step problem, but we took time to break it apart and think about the parts separately, because that's a strategy that you might use when you're taking a test and you read a whole problem together. You might think about breaking it into parts and thinking of the parts separately so that you don't forget a step. So let's